Hello, good afternoon everyone. My name is Mohammad Parvez, faculty of Mechanical Department, ISL Engineering College. After completing my Masters in Mechanical Engineering with specialization in computer-aided design and computer-aided manufacturing, I have been working as an assistant professor at ISL Engineering College for 4 years. During my tenure, I have taught many core subjects like engineering mechanics, fluid mechanics, strength of materials, finite element analysis, and hydraulic machinery and systems, CAD/CAM. And in this semester, I will be teaching one of the core subjects for both civil and mechanical department. That is finite element analysis is the name of the subject for mechanical department. FEA is for mechanical department, and finite element techniques is the name of the subject for civil department. However, the starting 2 units are same, so this will be a common lecture for both the departments. So your respective videos will be posted in your group so that there will be no confusion. So let's get started with the subject. So finite element analysis is one of the modern techniques which is employed by many departments, especially in the field of mechanical, civil and aerospace, to analyze the different complex engineering problems. So all those problems which are very difficult to solve by using the techniques of strength of materials, so we can use or we can solve problems other than that also, so which cannot be solved by using the conventional formulas which we have used there. So you might have studied about the different softwares like modeling software. One of the commonly used modeling software is SolidWorks, and civil engineers might have used Revit, and for analysis purpose you might have used ANSYS. Okay, these are design softwares, ANSYS and StatPro, NISA, Nastran, Abacus. So all these are analysis softwares. So what runs behind these softwares is the techniques which we are going to study in this subject. Like what you will be doing is you will be preparing a model in SolidWorks or you would be preparing a model in Revit. What I can do is I can export this model. I can export this model to ANSYS or any other design softwares. So what I can do in this, because I would not be able to apply loads here, I can only create a model. For instance, I prepared a cantilever beam here or a condenser here. So what I would do is, since I would not be able to apply loads, I will export this model to other software. So that is my analysis softwares. So what I can do here, I can apply loads and I can give boundary conditions, so that which is the most critical part of that model I can analyze. So why I am finding that critical part? Because if at all that model breaks in the future, the critical part will be the starting point of failure. So in order to understand this, let's take one simple example which we have this problem which you might have solved in strength of materials. Okay, let's take a bar which is subjected to a load of P is equals to some 1000 newtons. So let's say L is the initial length of the bar. So what will happen because of this point load P? Okay, so this is the fixed support. So when I am applying a load P is equals to 1000 newtons here, so the length of bar will be increased. So we were finding this increase in length of the bar dl by using the formula P into L by A. This is what we were doing in strength of materials. Okay, so dl, so we would have got the increase in length. We would also be able to find out the stresses. Stress is equals to load by area. So why we are finding this stress value is to see whether this stress is crossing the ultimate stress of this material. If it crosses the ultimate stress, what will happen? It will reach the breaking point. So once it reaches the breaking point, this will break. Okay, so this member will fail once it reaches its breaking point. So that can be analyzed by finding out these stresses. So this is what we are able to do in these softwares also. Like we can find out the values of stresses in ANSYS, but I can't be able to apply loads in this software SolidWorks. So what I am doing, I am only making a model, because SolidWorks is a simple software. So I can make models here and I can export these models to any other analysis software. So I can apply loads, here, and I can find out the values of the displacement and stresses. So what techniques these softwares are using? These softwares are using finite element techniques. The main idea of this technique is to divide a model into number of small and simpler elements. So what a finite element software does is, what a design software does is, it will divide this model into number of elements. Okay. So after applying load, let's say I am applying a load of P is equals to 1000 newtons. So what will happen to each, and we can analyze what is the behavior of each and every element because of this load. Behavior in the sense, how much this node, how much this element will elongate, and what are the stresses developed in each and every element of this model can be analyzed by using finite element techniques. Although we have softwares available for this, why we are studying is to interpret the results in a better way, because sometimes what might happen is you might give loads and everything, and the results what you are getting might be wrong. So you can find out those results, you can use the calculation part mathematically, and you can correlate those results so that your results are, in order to find out whether the results you got in these softwares are correct or not. So that's the reason why we are studying this subject. Okay, so the simplest idea of finite element analysis is to divide a model into number of simpler elements called as finite element. So this is called as discretization. Discretization is the first step of finite element analysis. So your first step in finite element analysis is discretization. Discretization means the software will divide this element into number of elements. That is called as discretization. So that is the first step of finite element analysis, is to divide a model into number of simpler elements. So however, while solving problems, what we would be doing is we will divide it manually, but in software we have a direct step for that. That is called as, in many softwares we have mesh option. So when you click on mesh, it will ask how many number of elements and what is the type of element you would want to divide this model into. So that is called as meshing. For this meshing also specially softwares are there, like HyperMesh is one of the commonly used softwares for this. If you divide it into more number of elements and in a better way, again there is a software for this, HyperMesh. So what you can do is you can create a model in modeling software. Okay, so first step is you have created a model. Next step is to divide that model into number of simpler elements. So you can export this model from SolidWorks to HyperMesh. So what you have to do is, there are many extension formats. One of the extension formats, so what you might be doing is you will save this file in such a way that you can be able to open this file in any other software. So that one of the extension commonly used is IGES. So when you save, you have an option save as .IGES. So that is called as initial graphic exchange specification. So when you are saving this file in this format .IGES, you can open this file in HyperMesh. So here you can discretize or you can mesh, both are same, both are synonyms, both are same. Discretization or meshing anything is to divide into number of elements. So there is a software for this. HyperMesh is one of the commonly employed softwares for this. So next you can export this model again to one of these softwares to give the loads and to find out the values of stresses and strains or the displacements. Okay, so that's the introduction about finite element analysis. So next what we would be doing is we would be finding out the second step. First step is discretization. Second step is to form a mathematical model of each and every element, because we are not solving in this subject, we are not solving a problem by using a software. We have to do it manually in the exam. So we have to find out the mathematical formulation of each and every element. So that mathematical formulation of every element, first I will find out the element stiffness matrix. Why we are doing it in the form of a matrix? That is because our system, our software takes everything in terms of the matrices. For example, if I take it in terms of matrices, what I would be able to do is, for example, I am finding out the displacement of this element. I would be able to find out the displacement at this point and the displacement of this point. Okay, I am exaggerating this element and I am showing here. So this is the bigger view of this element. So I would be able to find out the displacement at two different points. So you would be able to understand once I start the problem. So for second step is to find out the element stiffness matrices. Next, what I will do, I will assemble all those elements and I will find out the stiffness of this complete model. So next step is assembling of stiffness matrices to find out global stiffness matrix. The global stiffness matrix will give us the stiffness of this complete model. Okay. So why we are finding out stiffness? Because what is stiffness? Stiffness is load per unit deflection or displacement. Since I am the one who is giving load, and when I am able to calculate the stiffness, I am giving the load. Being an engineer, I am giving the load because I have to find out the design. So once I am able to find out the stiffness, stiffness is denoted by K. So I can find out the displacement. How much, because of this load P, what is the displacement of this point or any other point inside this model. So next, after finding out the stiffness, next I will find out the force matrix. Next is substituting in finite element equation. The finite element equation is K into U is equals to F, because K is force by displacement. In finite element analysis, U stands for displacement, F is also called as force or load. So I can say that finite element equation is K into U is equals to F. After this, I can find out the stresses and strains. Once we are able to find out displacement, we can find out stresses and strains. So while solving a problem, these 5 steps we will be using to solve any long answer or short answers. So let's start with the simplest problems, that is called as bar elements. So this is a type of bar element. Why I am calling this as bar element? Because this is only subjected to longitudinal loads. Longitudinal loads, because this member will only have displacements in this direction. Okay. So if this load would be in this way, a cantilever beam. Why I am not calling this as beam and why I am calling this as beam? Because beams are subjected to lateral loads. Beams are subjected to lateral loads. Like we have beam here in this classroom, that's a beam. Okay. So beams always have lateral loads. So this is a lateral load. This direction along the length is called as, if there is a load along the length, that is called as longitudinal loads. If there is a load in the lateral direction, then what will happen to this member? This member will bend also. Okay. And also there will be a displacement in this direction, that is y direction. In this case, there is no bending at all. There is no bending because of this force. There is only displacement. Okay. But in this case, because of this load, because this is fixed, you will be having bending as well as the displacement in the downward direction, that is y direction. So this was called as beams because beams will have 2 types of displacements. You will have to remember, beams have 2 types of displacements. One is movement in the lateral direction, y direction, and as well as bending. In this case, you only have movement, but there is no bending. So this is called as bar and this is called as beams. So we will be solving, in the first unit, we will be solving the simplest problems, that is called as problems on bar elements. Okay. So these are called as one-dimensional bar elements. The reason why we are calling it as one-dimensional bar elements, because there is displacement only in one direction. Okay, there is displacement only in one direction, whereas for beams there are two types of displacements. Okay, so let's start the problems on bar elements. I will directly get started with the problems because theoretical part has already been explained, and I will give you the notes also in order to understand the theoretical part. So these are the 5 steps we will be using. So I will write down the formulas which we will be using for solving bar element problems. Bar problems. So the first formula is stiffness matrix. So first step is to find out the stiffness matrix. Of course, we will be discretizing manually, but there is a formula for stiffness. So stiffness matrix for bar. So stiffness is denoted by K is equals to A into E by L, 1 minus 1 minus 1 1. For now you remember it as formula. I will be explaining why this formula is in this way while we are solving problems. Okay, so K is called as stiffness. K is stiffness. A is area of cross section. E is called as Young's modulus, also called as modulus of elasticity. L is length of the bar or length of the element, also length. Okay, so these are the terms. K is stiffness, A is area of cross section, E is called as Young's modulus or modulus of elasticity, and L is length of the element. So that's the first formula for solving problems on bar element. So first we have to use this formula for finding out stiffness of each and every element. Okay, depending on the number of, it depends on the number of elements we are dividing that model into. So that's the first formula. You will have to remember this formula. Okay, so next, second step, what we will be doing is we will be forming all these stiffness matrices, then we will be assembling all these stiffness matrices. That's a method. Next we have force matrices. So what are the different types of forces we have? I will erase this part. So on a member or on a beam, what are the different types of force you can have? Okay, forces. So you can have a point force, next is self weight of the member, self weight of the member, because weight is also a force because of gravity. So there is also a weight force, it is because of gravity. Of course, whatever the analysis we are doing it on earth, so there will be gravity, so you have to take the weight force also into consideration. But sometimes the weight is negligible, so you can understand it by seeing the terms what has been given in the question. I will help you understand how to take this weight into consideration, or when to take this weight into consideration and when not to take this weight into consideration. Next is point force, self weight force, temperature force. Why I am calling temperature as force? Temperature load also we can say, force or load in a better way. Okay. So what will happen because of temperature load? What will happen because of temperature? For example, I am heating something. Let us say I am heating a fixed beam. Okay. So what will happen to this fixed beam? So when I am heating this, we know that solids expand on heating. Okay, this is a solid member, and when I am heating it, solids expand on heating. So since you have fixed supports on both the sides, the solid which I am heating wants to expand, but what the supports are doing, the supports are stopping this from expanding. The supports are stopping, the supports are not allowing it to expand. This solid wants to expand in every direction. It will expand in this direction also, it will expand in this direction also, it will expand in Z direction also. But along this direction of length, what the supports are doing, the supports are not allowing it to expand. So these supports are preventing it from expansion by giving some force, and because of this force the stresses will develop. Whenever I am trying to stop a member from expanding by giving supports in the lateral direction, what will happen? The stresses will be developed. So these supports are not allowing this member to expand, so the stresses will develop. If this would have been, if there would be no supports, what will happen? Every member has a support on this earth, but if there are no supports, then this is a case of free expansion. In case of free expansion, no stresses will be developed. In case of free expansion, because I am not stopping it from anything, I am not stopping it, it can expand in this direction, it can expand in this direction, this member can expand in all the directions. Since I am not stopping this from anything, so that's a case of, in this case, no stresses are developed. In this case you have stresses because the supports are preventing it from expanding. Okay, whenever, like if you want to do something and someone is preventing you to do from that thing, so what will happen in that case? Stresses will develop in your mind. So think in that way so that it would be easier for you to understand. So the supports are stopping this member from preventing, so stopping this from expanding. So in this case you have stresses develop. So there can be stresses develop because of temperature loads. There can be stresses which can be developed because of temperature loads. So you have point force, self-weight force, temperature force or temperature load. Next is UDL and UVL. We all know what is UDL, uniformly distributed load, and uniformly varying loads. Okay. So what are the formulas for these types of loads we have? Point load is simply a value, like we took one example there, it's directly acting at one point. So we will take that P. Okay, we will add that wherever we have point load, we will add that P in terms of matrix, because we are solving in terms of matrices. We will add this in terms in this way. Next is self weight. The self weight force is given by rho g AL by 2 minus 1. This is the formula for self weight. This rho is called as density of that material. What will the density indicate? The density will indicate the heaviness or lightness of any body. Mass per unit volume is called as density. So how heavy a body is, or what is the weight of that body, can be determined by using this term density. So that's the reason we have density in this formula. G is acceleration due to gravity. So of course weight is because of gravity, and the value of acceleration due to gravity is 9.81 meters per second square. A is area of the member and L is length of the member, and these are constant values. Okay. So that's the formula for self weight. Okay. This is point force, it's a direct value, we don't have any formula for that. So self weight formula is rho g AL by 2 minus 1 and minus 1 in the matrix. Okay, this is also a matrix here in stiffness matrix, and we have a matrix here. I will explain how we are using these matrices. Okay. So one thing many students what they make mistake in the final exam is when they are substituting rho in terms of, what they do is they substitute area in terms of millimeters, millimeter square, length in terms of millimeters, but what they do is they substitute G as 9.81, but G is 9.81 meters per second square. So there you should be very careful. So while substituting this G value, so G is 9.81. It's not just 9.81 constant value, you have units also. Okay. So that small g value is 9.81 meter per second square. So if you write down 9.81 here, this is in terms of meters per second square. So you should be substituting area also in terms of meters and length also in terms of meters. Okay, got it, I think. So if your area is in terms of millimeters and everything is in terms of millimeters, then you can convert this also in terms of millimeters. So you have to convert this meters in terms of millimeters. So you can convert, you have conversion. Okay, so 1 meter is, okay, millimeter. When I say milli means that is 10 power minus 3 meters. When I say centimeter, so value of centi is 10 power minus 2 meters. If you remember these two, it will help you in many ways to do the conversions, because the first step in solving a problem in finite element analysis is to convert the units in one form. So I want you all to remember these two techniques. One is, for me, when I say milli, it means 10 power minus 3. So 10 power minus 3 meters. When I say centi means 10 power minus 2. So centimeter is 10 power minus 2 meters. Apart from this, we have other values also. Kilo. When I say kilo, that means 1000. Like we say kilogram, that means 1000 grams. Like sometimes we say 2019 as 2K19. So K is 1000 there. So value of K kilo is 1000, 10 power 3. Sometimes we have mega. Mega is 10 power 6. Next is giga. Giga is 10 power 9. Okay. So I want you all to remember these 5 things. So these 5 things are sufficient for you all to do number of conversions. Okay. For instance, we have these two are in terms of millimeters, and I want to convert this in terms of millimeters. Okay. But what I know, millimeter is 10 power minus 3 meters. So what is meter? If I send this 10 power 3 to the other side, this will become 10 power 3 millimeter. So 1 meter is 10 power 3 millimeter. So 9.81. So in place of meters, I will be writing 10 power 3 millimeter per second square. Okay. So what I have done, in place of meter I have written 10 power 3 millimeters, because if I send this 10 power 3 to the other side, so it will become meter is equals to 10 power 3 millimeter. So meter is equals to 10 power 3 millimeter. So in place of meter I can substitute 10 power 3 millimeter per second square. So value of G is 9.81 into 10 power 3 millimeter per second square. You should be very careful while substituting these formulas when solving problems. Okay. So next is, so this was about the self-weight force. Self-weight force formula you have to remember, rho G A L by 2 minus 1 minus 1. Okay. Next is the formula of temperature force. So temperature force is given by E A alpha delta T minus 1 1. E A alpha delta T minus 1 1, where E is called Young's modulus. Okay, we have already written here Young's modulus or modulus of elasticity. A is area of cross section. Alpha is called as coefficient of thermal expansion. Alpha is called as coefficient of thermal expansion. You might have come across this term while you were solving problems of strength of materials. Coefficient of thermal expansion, this value will determine, because of temperature, how much my member will expand. For instance, in order to, I will give you a brief overview of coefficient of thermal expansion so that it will help you to solve the problems. So let's say you have two members. Let's say one member is steel, okay, and you have member, same length member is there, let's say copper. So this coefficient of thermal expansion is a material dependent value. Like the coefficient of thermal expansion of steel is 12.1 into 10 power minus 6 per degree centigrade, and coefficient of thermal expansion of copper is 18 into 10 power minus 6 per degree centigrade approximately. So what will happen is, because of these values, if I am increasing this member, if I am heating this member by 1 degree centigrade, the strain in this member will be 12.1 into 10 power minus 6. That will be the strain in this member. If I am heating copper by 1 degree centigrade, the strain in copper will be 18 into 10 power minus 6. That means strain, what is strain? Strain is the change in dimension compared to its original dimension. Change in length by original length or change in diameter by original diameter. So what will happen? So my steel will elongate less because the strain is less. The strain is less. Strain is change in dimension. So for every 1 degree centigrade, the change in dimension of steel is a bit lesser as compared to the change in dimension of copper. Copper will elongate more because copper has more coefficient of thermal expansion. Steel has less coefficient of thermal expansion. So copper will elongate more and steel will elongate less.